Welcome to a Magical Math Monday, everyone. Today we are learning to complete the square. We have been reviewing so far converting from vertex form and going to standard form, and then from standard form you can get to factored form. So we know we can do that. But here's our standard form. We know that we can take standard form and convert that to factored form. That's what we learned last unit. And going from vertex form today, we can convert that to standard form just by expanding this exponent and then collecting our like terms. It'll give a standard form. Then we can factor it. That's great. But what if we want to go from standard form to vertex form? Let's take a look, everybody. So going to vertex form here, we just expand it to go back to standard form. That's what we've been practicing here. And then from standard form, we can get to factored form. I don't know any way to go between factored form and vertex form, to be honest. To me, I would always go through standard form to get from one to the other. But if we want to go from standard form to vertex form, that's the topic of today's lesson, and it is CTS. Oh, that means complete the square. So we're going to be taking a look at completing the square. So just to review, the x and the y, these indicate the relationship between the x values and our y values in our parabolas. The h and the k gives us the location of the vertex at point hk, and then a is our stretch factor. And so if we look at these parabolas, we notice that this one opens downwards, so it has a maximum value. That would be where our vertex is, and this is the vertex, it's 5, 5. And this one is over there at a negative 6.5, negative 5. And it has a minimum value there of negative 5. Okay? This one has a positive a value, it opens upwards. This one has a negative a value, opens downwards. All right. So now, here's the steps for completing the square. I don't have access to the printer today. I'm not going to leave this up here, but I will get you a printout of this to show you how to do it. But I'm going to show you several examples right now so that you can see how to do it. So, completing the square, basically, I'm going to show you a video where I'm going to teach you to think about it as like if you have x squared and then you're adding some b times x, this is your bx term here, we could split that b term into halves and create most of a square there. This would fit on this side and that would fit on that side, but we'd be missing a little piece. This is a piece that we're going to add in and subtract at the same time so that we don't change the value of the function. It's like me saying I'm 41 plus 10 minus 10 years old. I could also say I'm 41 plus 1 minus 1 years old because I'm still 41, right? Until after the break when I see you. So these are all the same things. So these are the pieces that we're going to add in and then subtract again. This video will help us make that a lot clearer over here. So this is a visualization of this idea, and to avoid a copyright strike, I'll just pause my video recording as we're going. But hi there. So that's a great way to visualize this. So if you're actually watching this at home, you can go ahead and search up this video, Completing a Square Using Algebra Tiles, a demo. It's a great video to show you what we're going to be doing algebraically. Now the good news is you don't need to cut out algebra tiles every time we want to convert a quadratic from standard form to factored form. So let's take a look at how we do it.
Are you gonna get those tiles?
No, we could make some. I could find some. We could play with them another day. So now, if we wanted to work on these quadratics, we might want to have some m value over here that's going to make this a perfect square. And here's how we're going to find this m value. So this is going to be something you're going to want in a note for completing the square. So over here, I have x squared plus 20x plus m. So if I imagine that, I would have, you don't have to write out the imagination of this each time, but this is x and x. So this is x squared. And then I'm going to have 10x this way. This is 10 times x. So this is an area 10x. And then this is 10 times x over here. So this is also an area 10x. Notice I've just taken this 2x and I split it in half. Okay? So I would want something in here that makes this a perfect square. Well, can people see that that would be 10 times 10? It's 100 here. So m equals 100. And here's how you do it. When a is 1, when I'm not multiplying x squared by anything, I take b I divide it by 2. So I took 20 and I split it up into 10 and 10. And then I square it. So that would give me 20. So that one, for example, that would be 20 divided by 2 squared equals 10 squared equals 100. That's this one here. That's this m is 100. Okay?
Just like with the 100, like how do you know like that someone's there?
How did I know that was 100?
Yeah.
Oh, because, well, when I visualize it this way, Johnny, I know that I could split up the 10x there and the 10x there, and that would make these two sides of a square.
Okay.
To fill in that corner, I would need 10 times 10, which is 100.
Okay, cool.
But then algebraically, I don't want to have to imagine that every time. So algebraically, all I do is I take b, I divide b by 2, and I square the result. So 20 divided by 2 squared is 10 squared is 100. Now this one, here, let's, rather than visualize the negative 4x, let's just do negative 4 divided by 2, square that. Well, that would be negative 2 squared. Negative 2 times negative 2, what flavor for? Negative 2 times negative 2? Positives. Two negatives there. So I've changed. I have two negatives, so that's back to positive. It's like turn the lights off and turn them back on again. Okay. So that would be m is equal to 4 in this case. And let's just try it. If I had x squared minus 4x plus 4, and I said factor that, well, that would be two numbers that multiply to positive 4 and add to negative 4. And that would be negative 2. So this would be x minus 2 times x minus 2. And then that would be, that's a perfect square. That's x minus 2 squared. Same thing up here. If I want to write that one as a, if I want to factor x squared, let me get some more space here. This way, okay? And I'll zoom in, there. And I want to factor x squared plus 20x plus 100. So x squared plus 20x plus 100, if m is 100. There I want two numbers that multiply to 100 and add to 20. Well, that's 10 and 10. So that factors to x plus 10 squared. Perfect square. Just like we predicted over here. Oops. So over here. X plus 10 squared. That's the square x plus 10. Okay. So now let's try some actual completing the squares with these examples. So go ahead and write this example down in your notes, and we're going to complete the square together. So my first step for completing the square here, because a is 1, it's going to be easier. He looks at the clock and realizes the clock's not there. So I'm going to write this out, but I am going to have x squared plus 12x, and then I'm going to add and subtract something to this so that I get a perfect square. Let's see, 12x. Well, if I take 12, I divide it by 2, and I square the result, that would give me 6 squared. Notice I don't need these brackets because this is not negative. And that's equal to 36. Okay. So here, what I'm going to do is I'm going to add 36 to this equation, and I'm going to subtract 36 from this equation, and then I still have this minus 10 over here. This will be my next step. Notice I just added and subtracted the same thing. I'm 41 plus 36 minus 36 years old. I'm still 41. So I did not change this function. It's the same. Yeah. So here, this one here, this is a perfect square trinomial. So let's factor it. Two numbers that multiply to 36 and add to 12, that's 6 and 6. Is perfect square. So here, y is equal to x plus 6 squared minus 36 minus 10 minus 46. So now I know that this parabola here has a vertex at the point -6 and -46. Also, this will not factor over the integers because I can't multiply to -10 and add to positive 12. But let's graph it in Desmos and see what they look like. X squared plus 12x minus 10. So I go to Desmos to check my work, and let's leave that one there. X squared plus 10x was plus 12x minus 10. Yeah, so let's see. Was that the one that we had? Let me see. X squared plus 12x minus 10. So what did I write? Plus 12x minus 10. So here is that parabola. Notice it has a non-integer x-intercept that's between 0 and 1. And then this one over here is like 12.7. So these are the two numbers that multiply to negative 10 and add to positive 12. You need the quadratic formula to find those two numbers. Does not factor cleanly over the integers. Still has two roots though. The y-intercept is given down there at minus 10, and the vertex is down here at negative 6, negative 46. So let's check that and see if that's what we had over here. Oh, negative 6, because that's a sign flipper, negative 46. Ding, 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 ding. It's the same. Okay, let's try another example. Let's determine the vertex here. So x squared minus 12x plus 23. Write down this example in your work. And we're going to do it for our first step. Y is equal to x squared minus 12x. But then I'm going to add and subtract something here. So I'm going to have minus 12 divided by 2 squared is equal to, again, negative 6 squared. But negative 6 squared, again, that's going to be positive 36. But another tip, this number that you get in here, b divided by 2, that's the number that's going to be with your x when it's inside the bracket squared. So that's going to be here plus 36. And there's my perfect square trinomial right there. Minus 36 plus 23. Okay, so this will be equal to y is equal to, this is x minus 6 squared. See, I get the minus 6 from in here. Or I look at this, multiplies to positive 36 and adds to negative 12, negative 6 and negative 6. Minus 36 plus 23, well, that will be negative 13. Negative 36 plus 23 is going to be negative 13. You calculator if you're confused. So it's negative 13. So there, this is another one that we won't be able to get this to factor evenly, but it does go. It will have two roots, and this is where its vertex is going to be at positive 6, negative 13. Okay? So that's how we do those. So then that's all you need to get started on the textbook work. Hannah, continue lesson now, or let you get started on this textbook work and then do second lesson after break. Okay, everyone, so that's 5.1, how to use completing the square to transfer these from vertex form to standard form. I will do a couple more examples where A is 1 on the board after the video, so you can have them on the board to model for your answers. And the questions in your textbook 270, number 2, 3, 4, and 5 are you will practice this skill. Next, we will look when A is not 1. So here, when we have a negative 2 or something, there's just one extra step that we need to do. It's not that much more challenge. Hannah?